What? Quiet! Quiet! Yes. No. Yeah. Don't worry, there's plenty of time. You will get them all. You can have a quiz every day. What's the matter with that? You'll have a quiz on the 17th, Friday, and the next one will be on the 23rd, which is the next Thursday, and then the test will be done on the 29th. Okay? Okay, so, quiet! If you don't be quiet, okay, I'm just doing detentions for a week at a time. You understand? We're already a half hour later than we should have been. Right? I have no patience for this. Okay, the quadratic formula you probably saw before. You should have seen it before. If you didn't, you're going to get plenty of it now. The quadratic formula ends up becoming one of the strategies we use to solve a quadratic equation. That's the same bullet that we used on the last slide, where we learned that we could solve by factoring, solve by graphing. So that becomes another strategy. And out of all the strategies we have, that's the only one that always works. Right? It always works. And just talking about SOLs, it's given to you on the test. So you don't have to remember it, which you should have to remember it, but you don't, right? It's right there in front of you. You just have to know how to use it. Now, there are a couple more things that come up that are just specific to the quadratic formula. You know, we learn about what's called the discriminant. And then we also learned there's a section in between this section, 4.7, and the one we just went over homework, which is 4.5. There's another one in the middle there. It's called completing the square. And I'm going to talk about it for a little bit right now, but we're not going to do any homework from it. I doubt you'll really use it as a way to solve quadratic equations, because what you're going to learn is the quadratic formula, it is completing the square. You're using completing the square when you use quadratic formula. So by completing the square, and that's the way you'll hear it referred to, right? Completing the square. It really means completing the perfect square trinomial, that thing that we've been factoring some already. Right? Completing the square means completing the perfect square trinomial. Let's see, I am right here. And I have to say that sometimes I abbreviate it, CTS. Right? CTS, completing the square. Right? By completing the square, what we mean is, if you have a first two terms of a quadratic trinomial, you figure out what you would put into the third position so that it turns into a perfect square trinomial. Right? There's some number that you could add there, a constant, that would make this expression equal x plus 3 squared. That's completing the square, figuring out that number that goes in that last place. Now, it's important that you only complete the square when the coefficient of x squared, equals 1. Right? You never do it unless you have a 1. So it's kind of like what we call the simple quadratic factoring. I mean, that's the situation where you do completing the square. If there's another number other than that in front of the x squared, you got to factor it out, which we'll do. Right? But we always have a 1 right there, and then we're going to go through this process of finding the constant that completes the square. Good? Lee? Good? Okay, so for that one, x squared plus 6x, all right, here's the steps. You take whatever is the b, the middle coefficient, the coefficient of x to the first, which in this case is 6, you divide it by 2, Okay, that's 6 over 2, which is 3. And then you square it. Right, so it's the middle coefficient, divide by 2, squared. That's what goes here. Yes, yes, those are the set steps. And now look at this trinomial that I created. It's a simple quadratic because the a is 1. And if you had to factor it, you just have to say to yourself, what are the two numbers, the factors of 9 that add up to 6? And you would say 3 and 3, right? That is x plus 3 times x plus 3, which is x plus 3 squared. Okay. What do you need? Okay, go to the other door, right? Okay. What does this say? Now. That's a now. Okay, so look at the next one, right? X squared minus 4x. Go through the same steps. Now that number is negative, so I take negative 4 and I divide it by 2, and I got negative 2, and then I squared it. Yeah, it says now on it, doesn't it? Okay. And I square it, and I got 4, positive 4. So notice that you're never going to have a negative number as that constant. It's always going to be a positive number. Even if the middle number is negative, when you square it, it better be positive. Right? So what perfect square trinomial did we just create? Or how would you factor x squared minus 4x plus 4? That would be the factors of 4 that add up to negative 4, negative 2, so, oops. Squared. Right, that's completing the square. Finding that number that you put in the last position, and it's a fixed set of steps. Half the middle number squared. Yes, it will. Were you listening? If we square a positive number or we square a negative number, you get a positive number, right? Yes. No. Do not interrupt me. All right? Okay. You ready? So find some numbers here. What number am I going to add to the first one to complete the square? Half of 10 squared. What is it? Right? 10 divided by 2 is 5. 5 squared is 25 plus 25. What about the second one? 16, right? Half of negative 8 is negative 4. Negative 4 squared is 16. Right? Always positive. I guarantee you, in doing this and in doing the quadratic formula, which also has something squared, we make a lot of mistakes because you put in your calculator here to do this one squared, you put in like this, negative 4 squared. And you know what the calculator tells you? Negative 16, because you didn't square the negative. You've got to know more than the calculator. Don't let that mistake happen to you, right? That's beneath us to make that mistake. You know that a square is always positive. Okay. So now that we know what the process is, I'll show you how you use completing the square or could use it to solve a quadratic equation. Like I said, you probably won't do it very often, but this would be how you use completing the square to actually solve the equation. Right? So notice that I've got my two terms on the left, the x squared plus 6x, that I'm going to complete the square with. This minus 3, I'm going to put it on the other side, right? Add 3 so that my first two terms are by themselves. So x squared plus 6x equals 3. Okay. Now I'm going to go through that process and figure out what constant will I add to the left to create a perfect square trinomial. Half of 6 is 3. 3 squared is 9, right? But now the difference between what we were doing before, we were just playing around with expressions. This is an equation. You can't just add 9 to one side of the equation without doing what? Adding it to the other side of the equation, right? So plus 9. So whatever you do to one side, you got to do to the other. Now, this on the left is a perfect square, right? How does it factor? X plus 3 times x plus 3, otherwise known as x plus 3 squared, which is 12. Okay, so if you're solving by completing the square, because right now you've isolated the x inside the parentheses, which is being squared, take the square root. Right, take the square root of both sides. What do you get when you take the square root of a square? They cancel each other out, right? A square root undoes a square. So all that's left on this side is an x plus 3. Okay. And what do you get when you take the square root of 12? No, you don't get 6. Yes. Oops, that was wrong. Plus or minus the square root of 12. Right? It's got to be plus or minus because the minus times the minus is plus, right? Okay, now you can simplify the square root of 12. How do you simplify the square root of 12? This is going to start coming up more and more. Is 12 a perfect square? Does it have any factors? Yes. The 9, because we added 9 here to complete the square on x squared plus 6x. Right? We did the half of 6 is 3. 3 squared is 9. That made a perfect square. But because we added it on the left, we had to add it on the right because it's algebra, right? Whatever you do to one side, you do to the other. Right? Okay, so the 12 is not a perfect square, so I cannot simplify all of this, right? But does it have any factors that are perfect squares? 4 times 3, right? So you're going to split this up into 4 times 3. The square root of 12 is the square root of 4 times the square root of 3. And then what is the square root of 4? 2. Okay. So this is actually x plus 3 equals plus or minus 2 times the square root of 3. Now, have we solved for the x yet? What's with the x that we still have to move? You got to subtract the 3, right? So when you subtract the 3, it looks like this. X equals negative 3 plus or minus 2 root 3. Yeah. Is 2 a perfect square? Is 6 a perfect square? That doesn't do you any good, right? You're looking for factors of 12 that are perfect squares, and 4 is a perfect square. That's why you can simplify it. It wouldn't do you any good to make it 2 times 6. Yes. Yes. In the main office, sure. Taylor, go to the main office. Main office. Okay? Quiet. No, they just said for a minute. Come back. Okay, so that's an example of solving a quadratic equation by completing the square. Now, it gets a little bit different if, like I said, if you have a number other than 1 in front of the x squared, then it goes like this. Right? Then you have to, I'm going to get the 6 onto the other side, right, like I did on the last one. 3x squared minus 12x equals negative 6. And then I have to factor whatever that a that is not 1 from the first two terms. So in this case, it's a 3. Right? So this is 3 times x squared minus 4x. Okay. Now, if you look at those first two terms, right? If I said factor the first two terms, what would have been the greatest common factor? 3x, because there's an x in both terms. That's not what you do. Don't factor completely. Just factor the a from the first two terms, right? And now complete the square on what's left in the parentheses, right? What number am I going to add here to complete the square on x squared minus 4x? 4, right? You get half of negative 4 is negative 2. Negative 2 squared is 4, okay? Okay, now what do I add to the other side because I just added a 4 on one side? 4. Not correct. 3. Because there's a 3 multiplying everything that's in the parentheses, that's actually 3 times 4 is what you just added. You added 12. So you need to add 12 to the other side. Like that. Right, you got to take into account that there was a 3 multiplying times the 4. And that's what you balance out. So now this is 3 times x minus 2 squared equals 6. Right? And again, we're trying to solve for the x. So I'm going to divide both sides by the 3. X minus 2 squared equals 2. And then now that I've isolated the squared term on the left, take the square root of both sides. Yes? What about it? Do you see where we got the 4? Okay, do you see why we added 12 and not 4? Okay, then how did I go from here to here? What two numbers? Their product is 4 and their sum is negative 4. Minus 2, minus 2. So this becomes this. Right? And then divide both sides by 3 because there's a 3 here. 6 divided by 3 is 2. Flip the sign? No, we added 12 to this side. So we have to add 12 to this side. You have to do the same thing to both sides. We're not taking a 12 from this side and moving it to the other side. We're adding. Yes?
Where did you get the 4 from? The plus 4?
Half of negative 4 is negative 2. Negative 2 squared is 4. Okay, then what would be the next step to solve? Quiet. Take the square root of both sides, right? Well, when I take the square root of x minus 2 squared, what do I get? Just the x minus 2, right? But on the other side, I get the square root of 2, but it has to be plus or minus. Always plus or minus. Now, I'm not quite done solving for the x. What's the next step? Add 2. So x equals 2 plus or minus the square root of 2. What? 3 times 4 is 12. We added a 4 there, did we? So we have to balance it by adding the same thing to the other side. That 4 is being multiplied by a 3. Okay? Okay, that is how you can solve a quadratic equation by completing the square. I don't find I ever want to do that. Okay, but it's important to those, at least one of those SOL things that we're supposed to know, which is kind of hard to test. But So you may or may not use the complete the square to solve quadratic equations, but you're supposed to know how that is how we figure out what the quadratic formula is. It comes from completing the square. We will in a minute. Okay. I assume you've had quadratic formulas sometime in the past. If you didn't, right, if this is, and we've already dealt with this, right, this is the standard form of a quadratic equation, right, it's ax squared plus bx plus c, where the a, b, and c are real numbers. Then this is the formula that you can, if you know those three numbers, you just plug them in and you get your values of x that solve the equation. Like I said, it's given to you on the SOL, and it solves every kind of quadratic. So let's say there's a problem that I give you, which is solvable by factoring. You just don't happen to remember the factors of a number. You always put it in the quadratic formula. It'll work. And then there will be others, which we get to not this class, but maybe after the next class, that actually the only way you could solve is by quadratic formula. Okay. What's your question? Sure. Josh, do not do that. Do you understand? Okay. Okay. So I'm going to derive the quadratic formula right now, starting from that and doing just the same thing we did when we solved a quadratic equation by completing the square. I am not going to stop and answer a lot of questions about it, okay? Because probably about half of these steps will blow some of your minds, and then some of you will go, oh, I can see it, okay? You're not tested, you don't have to do this process, but it is very accessible, and you ought to be able to do it, except most of your calculation skills are just so poor that you probably couldn't, right? But if you remember, when we had to solve the quadratic equation where we didn't have a 1 there, the first thing we did was we moved the constant to the other side, and we factored that number from the first two terms, right? That was the 2 slides ago. So this is what that would look like. A times x squared plus b over a x equals negative c. Right? I just moved the c to the other side, and I factored a from the first two terms. Now, since all you had was the b in the second term, that's why we got an a in the denominator. And remember, whenever you factor something from a term, you should be able to use distributive property and go back. A times b over a is b, right? The a cancels the a. Now, what was the process again that we used to find that last term? We take the b over a, this number here we divided by 2, right? So that number divided by 2 is b over 2a, right? There's the 2, that's dividing by 2. And then what did we do with it? Then we squared it, right? Well, if you square b over 2a, you'll get b squared over 4a squared. So plus b squared over 4a squared. Okay, but when I added something on one side, I had to balance it by adding something on the other, right? Remember that when we had the 3 outside parentheses, I had to multiply by that 3. So what am I going to have to multiply this time? The a times this. Okay, well, what will be the result of multiplying an a times this term? There's an a squared in the denominator. When I multiply it by an a, they'll cancel one of the a's, right? An a times this term cancels one of the a's. So I add this over here, plus b squared over 4a. Right? That balances what we just did right there. Okay. Now, this, we made a perfect square trinomial by what we did. That's why we did that process. And the perfect square trinomial is factored like this. X plus b over 2a squared. And you still have the a in the front. Okay. I think I got that right. Okay, now, remember, what we want to do now is take the square root of both sides. So we got to get rid of that a. So let's divide both sides by a. So that cancels that, right? And then we take the square root of both sides. You know, what do you get when you take the square root of a square? It cancels out. Now we've got x plus b over 2a equals, and on this side we've got plus or minus. Okay. Now, in order to add fractions, what do I need to be true? Common denominator, right? This one's got an a, and this one's got a 4a squared. Which door is that? Does somebody know? Okay. What am I going to multiply this one so it has the same denominator? 4a, right? I got a 4a squared here and just an a there. So I'm going to multiply this one by 4a over 4a. Now I've got negative 4ac plus b squared divided by 4a squared. Right? Now there's two things we can do that start to make this look like the quadratic formula. One, we can switch the negative 4ac plus b squared, just switch the order, make it b squared minus 4ac. Okay. And the square root of 4a squared is 2a. So that I can take outside of the square root because we can take the square root of 4, we can take the square root of a squared. Okay, now the last thing, in order to solve for x, we have to add this to the other side. Right? Subtract b over 2a from both sides. When you do that, you're going to get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And so notice that it's the same denominator. So if you put the numerators together and just have one denominator of 2a, that's the quadratic formula. So it is completing the square on the standard form of a quadratic equation. Right? And like I said, you're supposed to know that the quadratic formula comes from that. Whether you could do it yourself, okay, maybe not, but at least you know where it comes from. No. I think I said that before I started, right? Okay. Which leads us to now, okay, how do you use the quadratic formula to solve a quadratic equation? Right? Solve using the quadratic formula. Okay, remember, the quadratic formula started out with ax squared plus bx plus c equals 0. So you definitely need a 0 on one side, just like when we solve by factoring, just like when we solve by graphing. We always need 0 on one side. What do I have to do to this one? I have to add 12 to both sides. So that's just to get it in the right form. Okay, now the quadratic formula, again, is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So I need to plug in for the a, b, and c in this equation. Well, what are the a, b, and c in this equation? What is the a? Right? Again, if you don't see a number there, it's 1, right? So a is 1. What is the b? 8. And the c? C is 12, right? Don't write 1x squared or 8x, right? It's just the number. So now let's plug in these three numbers into that formula. X equals negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 12. Okay, now remember that 2a, right, it's not inside of the square root, and it's underneath both terms, right? That's what we always say when you say the quadratic formula. You always say all over 2a, right? Meaning this whole thing is over the 2a. Now you have to simplify. X equals negative 8 plus or minus the square root. Okay, now what is this going to equal underneath the square root? 8 squared minus 4 times 2. What seems wrong there? Oh, 4 times 12. Sorry about that. 8 squared minus 4 times 12. 8 squared, 64 minus 48. I'll write it out. 64 minus 48 divided by 2, right? 64 minus 48. 16, right? So that is and the square root of 16, we know that's a 4, right? So that is x equals negative 8 plus or minus 4 divided by 2. Okay, so now we got to get both answers from that. But this is where you got to know how to use the plus or minus, right? It's saying do this operation twice. Once use a plus in between those numbers, and once use a minus. So the plus will be negative 8 plus 4 divided by 2, and the minus will be negative 8 minus 4 divided by 2. Right, that's what plus or minus means. Do it twice. Right, the negative 8 plus 4 is negative 4 over 2, which is negative 2. The negative 8 minus 4 is negative 12 over 2, which is negative 6. Now, you could have factored that easily enough, right? What two numbers, their product is 12 and the sum is 8? 6 and 2. Right, x plus 6 times x plus 2, so the answers are negative 6 and negative 2. Right, they're going to give you the same answers. Good. Yes. You ready? Sandy? You okay? So you try this one. Try to do the same thing. So, I mean, this is a kind of a problem that if it said solve by factoring, we certainly could have done it. And I did it by factoring. So you could see what answers you're supposed to be coming up with. -1 and 1/3. Just if you get a question like this, which you could, right? It just says solve. It doesn't tell you how, right? Then you got to go through all the different ways we learned how to solve. So far, that's factoring, that's graphing, and that is quadratic formula. If you knew you had this kind of factoring problem in front of you, you might prefer to just plug it in the quadratic formula because it'll work. Anybody able to get those numbers? -1 and 1/3? You get it, Matt? Right? All right. I can't help you if you don't start. Plug in, plug in. Okay, again, you're supposed to by quadratic formula. Did you do it? Okay. You don't have to look on the other side. Did you plug in okay? It's not -8. No. Yeah. No. That a minus there and a minus there makes a plus. So it's actually 4 plus 12. Okay, let's go through this. X equals -2 plus or minus the square root of 2 squared minus 4 times 3 times -1, right? Divided by 2 times 3. Right, this is a common place to make a mistake, right? Because the formula's got a minus in it, but one of these numbers is also negative. That means it's going to be a minus a negative, which makes it a plus. Okay, so that's actually 4 plus 12, 6. X equals -2 plus or minus the square root of 16 over 6, which is -2 plus or minus 4 over 6. So the first one will be -2 plus 4 divided by 6, which is 2/6 or 1/3. And the next one will be -2, oops, that was wrong. -2 minus 4 divided by 6, which is -6 over 6, -1. Okay, you need to know this process. You need to practice these. You need to be checking your answers to make sure you can get them. Because if you can't deal with the one formula that always works and for which you're going to be given anyways, then there's not much hope. Yeah. What's that? For the quadratic formula, you just plug in the numbers and then you accurately calculate, right? And again, if you can't, then you better practice. You better do a bunch and try to get a bunch right. You're ready. Okay, solve using quadratic formula. What would I have to do first on this? We need a 0 on one side, right? It doesn't matter which way you do it. Again, I would prefer to move the x squared because it's negative over here. It'll be positive over here. Right, now, if you weren't told, solve this with a quadratic formula, then you might say, well, maybe I can factor it. Maybe it's solvable by factoring. Can you think of factors of -5 that add up to +6? No, it's not factorable, in fact. So you're going to have to use quadratic formula. So let's do that. X equals negative 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 5 over 2 times 1. All right, just plugging in for the A, B, and C. +36, what goes next? +20, right? Because it's a minus in the formula, but there's a negative number as part of the product. It's going to be minus a negative, which makes it a plus. Over 2. So X equals negative 6 plus or minus the square root of 56 over 2. Now, if you get to this kind of problem, you are expected to be able to simplify it as a square root without just turning it into a decimal, right? You're not going to get all the credit if you start just turning them into decimals because you can't handle a square root, because that says something. We have a whole chapter coming up, not the next one, the one after, where everything is a square root that has to be simplified by not turning it into decimals. So you look at 56 and say, is it a perfect square? No. Does it have any factors that are perfect squares? Which? What's that? 9 times 6 is 54. Okay? 4 times 14. Right, the square root of 56. We will break up the 56 to 4 times 14. Right, because we can simplify part of that. What's the square root of 4? 2. Right, so that's 2 times the square root of 14. So we're going to replace it here. This becomes X equals negative 6 plus or minus 2 times the square root of 14 divided by 2. And does it look like we're done? Because what? Say again? All of these things here are divisible by 2. So you could factor out 2. I mean, I could write it like this. Let me divide this off. Write it like this. X equals 2 times negative 3 plus or minus the square root of 14 divided by 2. Right? Just taking out the 2 from both of these. And that now you can see we have a common factor in the numerator and denominator. So cancel. So X equals negative 3 plus or minus the square root of 14. And that's, you can't really do much more, you just leave it like that. If you have an unresolved square root, then your answer will just have to stay with the plus or minus. I think in the homework, I give you like a variety of solved by quadratic. One, I think, will be one where you just get integer, whole number kind of values like the first one we did. One will give you fractions. When you get fractions like we did on the one, negative 1/3, that just means it was factorable. It just would have been the not simple factorables. And then you'll get one where it actually, there's going to be a square root in the answer. Okay. Okay, so does this look familiar as a factoring problem? It's the perfect square trinomial, right? Because this is a perfect square and this is a perfect square. And actually this is 2 times 2 times 3. So this factor is like 2x plus 3 squared. Which tells you that you could take it, the answer is going to be negative 3 over 2. Negative 3 halves. But this is what it looks like if you do the quadratic formula with that. All right, X equals negative 12 plus or minus the square root of 12 squared minus 4 times 9 divided by 2 times 4. Okay, what's 12 squared? right? 144. What is 4 times 4 times 9? Hunter? What'd you get? Same thing, right? It's 144. So x equals negative 12 plus or minus the square root of 0 over 8, right? And what is the square root of 0? It's just 0, right? Which tells you that our only answers here are going to be negative 12 over 8. Because it won't make any difference. If I add a 0 or if I subtract a 0, I get the same number twice, right? That's what happens when your equation actually involves a perfect square trinomial. So you can get, solving a quadratic formula, you can get 2 answers, like we did on all the problems up till now, or you can get 1 answer when it happens to be a perfect square trinomial. And there's actually one more possibility. What do you think that is? No, you would simplify that to negative 3 halves. Which you can see that solves this, right? Negative 3 halves would have made that 0. So that's okay. So everything depends. Whether you get 1 answer or 2 answers, it depends on that one piece of the quadratic formula, the b squared minus 4ac, right? Not even the square root part of it, just the b squared minus 4ac. Like we know right now that if that number is 0, we're just going to get 1 answer. If that number is greater than 0, we're going to get 2 answers. And that's called the discriminant. That's like the third SOL part of this, right? Solve equations, know that the quadratic formula comes from completing the square, and 3, understand how the discriminant tells you how many answers and what kind that you get. So the discriminant. You done that? Okay. So here's the 3 possibilities for the discriminant, right? And again, we're not calculating the square root part. It's just saying the b squared minus 4ac, when it's bigger than 0, you're going to get a graph that crosses in 2 places. You're going to get 2 real answer solutions. If the b squared minus 4ac equals 0, like the last one that we did, then you just get 1 real number solution. And actually on the graph, it looks like this. The graph comes down and it touches the x-axis, and then it goes back the other way. So that's why there's only 1 solution that comes out of it. And the book has kind of done this in a goofy way this year, to me. But this part here, we can't really say much more than if your graph, if the b squared minus 4ac is less than 0, that means your graph never crosses the x-axis, and that means there are no real number solutions. It doesn't mean there's no solutions. It means they're not real numbers, and that's what the lesson is next class. You know, what other kind of numbers are there? There's another kind of numbers. And so we will be coming back to this next class. Okay, so you're going to get some homework problems that look like this. Okay, it says evaluate the discriminant only. Okay, which it doesn't say only. It just says evaluate the discriminant. I added the only because we're not looking for the whole quadratic formula. Evaluate the discriminant and then say how many real solutions do you expect. Okay, in this problem here, right, we need to fill in the numbers for b squared minus 4ac, right? What is the a and the b? Negative 4, negative 5, right? So this is going to be negative 4 squared minus 4 times 1 times negative 5. 16 plus 20 is 36. So how many real solutions do we have? 2. Remember, if the b squared minus 4ac is positive, 2 real solutions. So the evaluate part means 36. The how many real solutions is what you learn from that. But you're expected to come up with the right number. Yes. Yeah, you don't need the whole rest. All you need is b squared minus 4ac. Okay. Yeah, let me finish this up. Try it with this one. B squared minus 4AC, what do you get? I think I got that right. All right, that first number is a 1, right? 4 times 20, 2 times 28 is 56. 4 times 56 should be 224. So how many real solutions do we have if what's inside the square root is negative? 0. Right? No, if this is 0, then there's one solution. Right? If what's inside is 0, then you get one solution. If it's negative, you get none. Okay? Now, the last thing just to mention is, when we talk about solutions, again, when we know what we know about solving an equation by graphing, the solutions are also known as x-intercepts, right? Because those are where the graph crosses the x-axis. So when you get to the homework, right, these first problems here, just solve with the quadratic formula. These here are evaluate the discriminants and say how many real answers you get. The last 3 are about x-intercepts. But when you see x-intercepts, you just got to think solutions, real solutions. That's it. So don't be confused by that.